Hi everyone, and welcome to Eric's Electronics Workbench. So on the bench today I have this TEAC A-3440 4-track reel-to-reel tape machine. Now I've owned this machine for about 15 years, maybe even closer to 20 years at this point, and it's an absolutely fantastic sounding tape machine. Now one of the reasons that it does perform so well is that it can operate at 15 inches per second, in addition to 7.5 inches per second. And among other things, when the tape speed is increased, the high frequency response is extended. So the tape machine really does perform quite well. Now, I don't use it every day, of course, but I do use it several times each year. And like anything mechanical, it needs maintenance. So I just recently went to use it and I discovered a problem, and it's really not usable in the condition that it's in right now. So let me get you zoomed in a little bit closer and let's start in with the repair and take care of the problem. So for the viewers that aren't familiar with a reel-to-reel tape machine, I'll go over some basics on the tape transport and the controls, and I'll show you what's wrong with this machine. So this is of course the supply reel and the take-up reel. You can see the supply reel is completely full. There's 2,500 feet of tape on that reel. And I have the tape threaded through the transport, and just a few turns are wound onto the take-up reel. Now, as the tape leaves the supply reel, it moves over this tensioning lever and this inertia roller, and the purpose of this lever and this roller, and also this lever over here, are just to help smooth out any erratic movements in the tape, any vibrations, and also to absorb any shock when the transport is first started. So, for example, when you go into the play mode and that initial movement of the tape, these levers can move like so, and it just takes up that shock that the tape could be under, and it avoids stretching the tape or damaging the tape. Now, as you can see, when this lever is moved, how the other lever is moving as well, but there's no mechanical link between those levers. That's just some slack in the tape on this side, and that's just taking up the slack on the other side. So there's some viscous dampening in this lever and some spring tension. Now, under this cover are the tape heads. So you have the erase head, record head, and then the playback head. And over here is the capstan and then the pinch roller. So this is just a rubber roller. This is a metal cover, so you can remove this cover if you have to service or remove that pinch roller. So in normal operation in the play or record mode, this pinch roller moves up and it squeezes the tape against the capstan. Now the capstan motor, which is driving the shaft, is what's responsible for, of course, powering the capstan, and that's what's moving the tape through the transport. But the capstan motor has to operate at an extremely steady speed. So any variation in the tape speed is reflected as a change in the pitch in the audio, and it takes very little change in the tape speed to have a perceivable pitch, so that you can hear. So it's very, very important that the capstan motor run very, very steady, a very constant speed. So of course, as the tape leaves here, it goes around this lever right here, and then it's taken up by the take-up reel. Now, if I put some slack in the tape like so, you can see that lever drops all the way down. If you listen, that click right there, so there's an electrical switch inside. So if this lever drops all the way down, when the tape ends, or if the tape were to break for some reason, that just shuts off the capstan motor, and the reel motors basically just shuts down the transport. So you have to have that lever up like so before you're able to start the tape machine. If that lever's down and you press the play button, for example, nothing will happen. Now if we look at this point at the capstan and the pinch roller, when this is squeezing at that point, just imagine for a moment that you're holding the tape right there and you don't allow the tape to move, and you pull back on the tape on this side. Okay, so you have tension from this point to here, and then you would have tension from this point to here. So this is known as the take-up tension, and this is known as the back tension. Now the back tension is extremely important because the back tension sets the pressure that the tape has against the heads. So again, as you're holding this, the harder that you're pulling backwards on here, it has the effect of pulling or pressing that tape harder and harder against the heads. So it's very, very important that the tape not drop away from the heads. The slightest drop from the heads will result in a huge loss in audio. It'll drop out. But you don't want too much pressure of the tape onto the heads. It will cause excessive wear on the heads, and it'll damage the tape. It can shed the oxide off, things like that. So the back tension is extremely critical that it be set correctly. And of course the take-up tension has to be set appropriate as well. Now, the back tension and the take-up tension are actually set by the torque that these reel motors are exerting. So this motor only can run this direction, and this motor can only run that direction. Now in the play mode, of course, the tape is moving like so. So this motor is turning in the direction that it wants to turn, but this motor is actually being pulled in the opposite direction that it wants to turn. These are a special type of motor known as a torque motor. So they're meant to be almost stalled out or turned in the opposite direction that they want to run. Now in the rewind mode, of course, this is turning this direction and it wants to go that direction for rewind, but now this one is going in the opposite direction. So a very clever design that they don't have to actually reverse the direction that the motors run, but the tape, depending on the operation of the deck, is pulling the motor in the opposite direction that it's trying to turn, and that is basically acting like a brake, and it sets the tension that the tape needs to have. So you do have tension, for example, in the rewind mode, you do have to keep some tension on this side so that the tape doesn't end up spilling and becoming very loose. So again, the back tension is very, very critical, and it's important that it be set correctly. Now, the actual torque that these motors put out is set by the voltage that's applied to them, and there are large power resistors inside that are adjusted, just a one-time calibration, and they affect the torque that these motors have depending on the operation of the deck and what mode it's in. Now you can see down here it says reel large and small, so these are 10.5-inch reels, so that's the large reel, and this switch is basically changing the torque that these motors are able to exert. Now a common misconception is that these flanges on the reels up here are to guide the tape. That's actually not correct. The tape is never supposed to touch these flanges. So if the tape does touch the flange, you'll hear a sort of a scuffing sound, and that's an indication that either the flange is bent inward, or there's something is warped, or that there's a misalignment in the tape transport down here. So without the flange on here, this tape that's in here is known as a pancake. So you can remove these flanges and just run the pancake by itself, and it will work perfectly fine. You don't need the flanges on here. Now, obviously, that looks a bit unusual. You see a machine like this, you're used to seeing the flanges. That's obviously normally how it's used, but again, the flanges are not actually guiding the tape in any way. So the purpose of the flanges is really just for you to handle the tape. It gives you something to touch, so you're not touching the tape pack. And of course, in storage, it's just protecting the tape. Now down here is a counter. There's no time reference to this counter. It's just an arbitrary reference on the tape. Pitch control, so if you pull this control out, rotate this knob, that changes the speed of the capstan, which of course is changing the pitch, the audio that you hear. Main power switch, reel size I already mentioned, speed high and low, so 15 inches per second high and 7.5 inches per second low. So in the high speed, you have a half hour of recording on a reel of this size, and on the low speed, this would give you 1 hour of recording. But again, the high speed extends the high frequency response, among other things. Also, the wow and flutter is much improved on the high speed. So depending on, the type of audio and what you're recording would dictate, what speed that you want to use and what's appropriate. The function select switches right here, 1, 2, 3, and 4. That's just enabling the record mode for those tracks. And then right here, the output select, so it says source, sync, and play. So source is just monitoring the input signal or your source, and play, of course, is picking the signal off the playhead. But the sync position is actually picking off the signal that you hear off of the record head. And the reason that that's done is that if you want to punch in and begin recording, you don't want to be listening on the playhead, but punch in on the record head, because what you've heard now has a space in, this much on the tape, and that's easily something that you can hear. There's an audible, shift. So by listening on the sync position, where you're listening on the record head, you could be listening, say, on track 1, punch in on track 2, and when you do so, you're actually punching in exactly at the same spot that you're hearing. So any deck like this that's for multi-track recording will have that sync mode. Now, this deck shouldn't be confused with a 4-track type machine that's a stereo deck, because stereo 4-track, think of a typical cassette type tape. You have 4 tracks, but 2 tracks are recorded one direction, then you flip the tape over, 2 tracks are recorded the other direction. In this machine, all 4 tracks are recorded in one direction. So the transport controls over here, nothing too unusual there. Mic inputs for convenience here. The VU meters, volume units, monitoring the inputs, outputs. Level controls down here, various selector switches for what you're monitoring here. Mic attenuation, mic line, same thing's repeated on all of the input channels. And over here, headphone output, a monitor level for the headphones, and then the track that you want to listen to, 1, 2, 3, 4, you can have any or all combinations selected. So let me grab the power cord over here, reach around like so, get this plugged in here, right there, and let's take a look at what the problem is. So turn the power on. Alright, so I will hit the play button, and you can see that tape is running way too fast. It's just speeding up faster and faster. And if you took a close look right here, this pinch roller did not actually move up and contact the capstan. In fact, you can see the capstan is still rotating right there. So nothing was happening when this moved up. It didn't, maybe moved up a little bit, but it didn't come up far enough to squeeze against the capstan. So that's definitely a problem. There's something is bound up, and it's very likely to be old grease or oil that has become very stiff in the mechanism, because it does try and move just a little bit. But actually, it's very stiff. I don't want to damage that by pressing on that too hard, but it did try and move a little bit, so I don't think it's an electrical problem with the solenoid. It's probably just, like I say, old greases and oils that have gotten into it. I've had the problem on a TEAC X1000R a while back, and had a similar issue. The mechanism got extremely stiff in that deck as well. So I think that's the problem here. But we'll take a look inside here just to see exactly what's going on. Press that again. You can see how it tried to move up, but it's not actually squeezing. I think if I push this, yeah, you can see it wants to move up further there. I don't want to hit that one that's running there, but yeah, it's extremely stiff. So that's definitely the problem. So let me reposition things a little bit here, get the back cover removed on this machine, and we'll take a closer look inside. All right, a few screws and the back cover is removed. So you can see the brake assembly that's on each of the reel motors. So there's a solenoid below each of the brakes, and when that solenoid is activated, it releases the brake band. So you can see how easily that motor spins, but when I activate the brake like that, it stops very quickly. Now these brakes are designed to grab tighter in one direction of rotation than the other, so if I turn the motor like this, it has some resistance, but it turns fairly easily still. But if you turn it in this direction, it's much more difficult to rotate the motor, so again, that's just by design. You can see there's a sensor over here to detect rotation on that motor. A large capacitor right here, that's part of the reel motor circuits. Very large power transformer. If I tip the cabinet here, it's very heavy, but if I just tip it back like so, you can see those green colored power resistors. So there's 3 over on the right hand side, and you can see right over here there's one more. So those are the power resistors that are used to set the torque value on the reel motors. A whole bunch of fuses up there as well on that top circuit board. So this is the capstan motor. You can see that there's a shielded wire and then unshielded wires. So there's an electronic TAC control, so it holds the motor speed very, very constant. And there's a belt between the motor and then this very massive flywheel down there. So that massive flywheel has a lot of inertia and helps keep the capstan running very smoothly as well. So there's only 2 belts in this whole machine. The one belt on the capstan, and there's another long belt that goes from this reel motor down to the counter over there. So everything else, on the reel motors is all direct drive. So a lot of circuit boards down on the bottom, the control electronics and all the audio circuits. Nothing too exciting going on down there. A lot of discrete components, almost no integrated circuits in the whole unit. In fact, I don't know if there are any integrated circuits at all. Everything's discrete transistors. And over here, power supply, some power control circuitry going on. On the back panel, nothing too interesting going on down here, just the inputs and outputs. You have the optional DBX noise reduction, so decoder and encoder lines, and the control signal for that optional DBX unit. It was made by TEAC. It was meant to be used with this unit. The line in and the outputs for the 4 tracks, and right here is the optional RC70 remote control. All right, let me zoom you in a little bit closer here, and we can take a look at where I think the problem is at. So you can see this very large flywheel right here that turns for the capstan. So the pivot point that I think has become very bound up and not working correctly is right here. So this screw goes through the center of what looks like a kind of a hollow tube. There's a solenoid right up there, and that's the pinch roller lift solenoid. So I hope I don't have to remove that solenoid because it's set and it has some slots for its mounting position, and it's real critical on exactly where it's mounted. So I hope I don't have to mess with that. But it looks like the first thing to do is remove this screw, and also this screw. This bar can be removed, and that looks like there's probably a thrust button back here that's part of the bearing assembly for that capstan. So I'll remove this and see what kind of access that gives to this pivot point, and I'll start with that, and then I'll show you what I found out. So this is quickly becoming a more complex disassembly. You can see I have that crossbar removed, but the actual problem is that this hollow shaft right here is seized to the shaft in the center. Of course, that's the pivot point for the pinch roller. So to remove this whole assembly, it looks like I need to remove the flywheel and probably the switch down here, because the assembly and lever goes in behind that switch, although it's not attached to it in any way. Now, this spring tab that goes up to the solenoid has 2 screws right there, and of course they're facing right into the flywheel, but by removing that flywheel, I'll have access to those as well. Now, this mechanism, goes in behind the flywheel, and I thought, well, if the flywheel can pull out, but no. You can hear that, how it just thumps against there. So it looks like the shaft has to go out the front, and there are 2 set screws that are holding the flywheel onto the shaft. So I can remove those, and then, of course, the shaft can be removed and just take the flywheel out. Now the shaft extends right here. You can see this sort of rounded end that it has to it, and it extends beyond the flywheel by 0.9 millimeters. So that's very critical that that be set, to that exact value for the clearance on this bearing. So I can easily, reset that when it's reassembled. So I'll continue on with the disassembly. Okay, everything's disassembled to the point that I can remove this arm assembly that holds the pinch roller. However, it seized so tightly at this pivot point that I can't actually get it to move. So I think the next thing to do is to try and heat this with a heat gun, and hopefully that'll soften the grease that's gotten in there, and then I'll be able to, move this arm off of the center shaft. So you can see I have that switch down there just tipped out of the way, so I loosened both screws, just moved it over, and then tightened the bottom screw just to hold it out of the way. And then this spring tab that goes up to the solenoid has 2 screws, so they've been removed, and it's just holding in position with the spring that's up in the top. And the 2 screws that were holding this tab over to the arm were just incredibly tight. Of all the hardware in here, they were the most difficult to remove. I think they had some Loctite on them. They're not that large of a screw, but they were very, very tight. And you can see with the flywheel out of here how the arm extends, behind where the flywheel runs. So absolutely necessary to remove that flywheel. And of course, this is the back side of the bearing for the capstan. So I also noticed that the tape lifter arms over here are pretty stiff. So I'll take a look at those as well and get those cleaned up. They aren't really moving the way that they're supposed to. So let me just move the camera over here, and you can see some of the parts and pieces that have been removed over here. So of course the very large flywheel, some of the other hardware, and then this capstan assembly right here. Get this to focus. So you can see the shaft is very delicate. The slightest scuff or nick on that shaft would absolutely ruin it. So I put it in this plastic bag just to protect it. And you can see where the set screws go into the shaft. There's actually a recessed area right here, which is really good because when the set screws go in, it can cause the metal around where the set screw touches, to kind of mushroom out a little bit. And if you had that on this outer area right here and had to pull that through the bushings, in the bearing that's over in the tape machine, it would absolutely ruin those bronze bushings. So it's a really good idea that there's just this little notch, right here for the set screws to go into. So this looks very good. There's no scoring or any damage or anything on it, so it looks fine. A little rubber sort of a washer right here. I think it's just to help cushion it and possibly just to block any oil from getting up into the capstan right here. This discoloration is perfectly normal on these capstans. That's actually a ceramic material, I believe, on the end. So that's normal. It really doesn't have any effect on the operation. Just discolors a little bit. So yeah, that looks really good. No problems there. I'll put a little bit of oil on that shaft when it's all reassembled, just a drop or 2. That's all it needs. So I will continue on with heating that arm assembly, and then I'll show you what I find out. Alright, so using the heat gun worked very well. I just heated up this piece right to the point that it was getting uncomfortable to touch, but not so hot that it's damaging components in the area, and it allowed these 2 pieces to slide apart. Now, they didn't just fall apart, it still took a little bit of effort, to get them to separate, but without using the heat gun, it was like they were absolutely welded together. So now I can start with the cleanup and then reassembly. Now, you want to be very careful of this surface right here. This is where the pinch roller runs, so it's the bearing surface. You don't want to score or scratch that area. Now, this piece right here on the end is where it attaches to the front panel, so there's a screw that pokes through the front panel, threads into that end. And let me just move the camera over here, pardon the movement, and I'll show you where that attaches. My flashlight here. So if you look right there, right above my finger, right there, so that screw that's poking through, so that comes through the front panel. But if you look over here, you can actually see how the front panel has a vernier that's on the other side, so that's like a decorative vernier. And so the head of that screw is actually hidden. So if you look right there, see how there's a vernier that's in that cutout area right there? So it's not a problem because the head of that screw, you don't actually have to, hold it in any way. You can take this piece right here, and when I start it on there, just get it to catch a little bit, and then just angle it slightly and just wedge that screw just a little bit, and then you can turn this shaft and it'll thread right back on. So that shouldn't be any problem at all. So I'll continue with the cleanup and reassembly, and I'll show you when I have an update. So it's just the process of putting everything back together now, and this pinch roller lever assembly is working very well. No binding, moves very easily. So here's how you can set the distance that the shaft needs to extend beyond the end of the flywheel. So we know that it was 0.9 millimeters because that's what I measured before I took it apart. I suppose other machines could be a different value, so make sure to measure it before you disassemble anything. So take the flywheel and press it all the way in, because you can see there's clearance like so, and that clearance, it won't be allowed to move out this way when this crossbar is in place, but for now make sure it's pressed all the way in, and bring the shaft out just a little bit. Again, you're not tightening the set screws yet, so the shaft just visually is extending beyond what the value that that it needs to be set to. And then use some calipers like this. Let me get this to focus here. So preset the calipers to the value that you need, in this case 0.9 millimeters, and then lock the calipers so they don't move anymore. Okay? And on the end of the calipers, you can see this little rod that's sticking out on the end. So the distance from the tip of that rod to the flat part of the end of the calipers is 0.9 millimeters. So then if you go like so, and you take the calipers and make this little rod that's sticking out touch against the flywheel, and the shaft touches the end of the calipers over here, and you just go in here like so, and you press inward, you'll be pressing the shaft in, and when everything bottoms out, then you've hit that 0.9 millimeters, okay? Then the next thing you need to do is just to double check it. So loosen the calipers, make sure that they are zeroed up when they're closed, okay? And then lock the set screws, of course, you don't want anything to move there. Take the calipers and just open them up a little bit, like so, just to some random amount. And then come in here like so and do the same thing all over again. This time just checking for the measurement, and just take the end of the calipers with your thumb, you're going to see down here, and I'm just going to press inward on this outer piece of the calipers right here. Just press it like so. Right there. And look at that. Perfect. 0.9 millimeters. So that worked out very well, and that is the correct value. Alright, everything's back together on the inside of the reel-to-reel tape machine. Now, if I take the flywheel, and I don't know if you'll hear this or not, if I pull back and forth in this direction, just that slight little clunk back and forth, and that's exactly what you want. So there's just a very, very small amount of end play in this direction. So when this crossbar is installed and this thrust bearing is in place in here, you don't want it so tight that there's no end play, and of course you don't want it so loose that this is just flopping back and forth. It needs to have just a tiny amount of clearance, and that's perfect. And see, it spins very easily as well. So I'll put the pinch roller and some other pieces back together on the front panel, and then we'll try it out. Okay, the TEAC A-3440 is completely reassembled, so let's try it out and see if it works correctly. So reach around over here and grab the power cord and it's plugged into the bench outlet right there. Alright, and reach around on the other side and hit the power button here. Alright, lights turned on, no problems there. So just take up the slack in the tape. Alright, no problem there. So the capstan has started, the motor is running. Very quiet, no issues with that. So I'll go ahead and hit the play button. Looks like tape is at speeds on low and the reel size is set to large, so everything is good. Other controls aren't really important at this point. There's no audio on the tape, this is just a test tape, so it's been bulk erased. So perfect, no problems. So that pinch roller snapped right up into position, engaged right away. So actually take that back, there is a little activity on that track, a little bit of movement there on that view meter. So if you're not familiar with a bulk eraser, they look like a large electromagnet they plug in the wall, and you run them over the reel of tape, and it just bulk erases the tape. And that's what I did on this tape the last time I used it, and this is just a test tape that I use. But it looks like it didn't quite get all the signal erased. But that's okay, no problem with that. So that's working very well. Let me reach around over to the other side, and I will just hit the speed. And that's 15 inches per second. No problems with that. Very quiet very smooth when it runs. Let's try stop, back to play again. Perfect. Fast forward. No problem with that. Hit rewind. Yeah, it's working very smoothly, no problems. So I'm very happy with that repair. That's looking very good at this point. So if you enjoyed this video, please remember to give it a thumbs up. And if you're enjoying the videos on this channel, don't forget to subscribe. There'll be many more videos coming up in the near future. So this tape machine is definitely ready to put back into service. I'm looking forward to using it again. So thank you for watching, and until next time, take care. Goodbye for now.